Okay, this is the lecture number 1, and it should take about 10 minutes. And the title of this chapter is Introduction to Fourier Series. The knowledge that you learn from this lecture should help you to understand later on about the Fourier series, and also to understand about the discrete Fourier transform, as well as the fast Fourier transform. Let me start here with some background that you need to know. As you can see on the screen, we have 5 equations here, 1, 2, 3, up to equation 5. The relationship among those equation 5, for example, let's say the integral of psi of k omega 0 t dt is equal to 0. These 5 relationships we need to know so that later on we can apply these 5 equations to understand about the theory of Fourier series. So in the next few slides, I will explain to you what is the meaning of this equation and how do we derive those equations 1 through equation 5. In all of the previous 5 equations, the symbol omega 0 equal to 2 pi f, where in this equation 6, omega 0 represents the angular frequency, and that is equal to 2 pi times f. And f is defined as the frequency, which is equal to 1 over capital T, where T is a period. Now, if we substitute equation 7 back into equation 6, then we will have 2 pi times f, which is the frequency, but that is equal to 1 over t. And therefore, from that relationship, we can see that if you take omega 0 times capital T, omega 0 times capital T, and that will give you the answer as 2 pi. Okay? So omega 0 times capital T equal to 2 pi. We'll make use of that relationship later on. Now let me give you some definition. A function is called a periodic function if it satisfies equation 8. And basically equation 8 says the function value at the time t should be equal to the function value at the time t plus capital T. Alright, in the next slide, I will go through some examples to help you understand better. For example, let us try to evaluate the integral from 0 to capital T of sine k omega 0 t dt. The value of that integral, let's say right now we say it is equal to a. And right now I will try to figure out what is the value of a. Well, you can see based on high school year, the integral of sine is equal to the negative of cosine. And then on top of that, using the chain rule, we have to multiply with the factor 1 over k omega naught. After you do the integration, you have to evaluate between the lower limit, which is 0, to the upper limit, which is capital T. So if we evaluate that equation at the upper limit, we just replace a small t with the capital T. Okay? And then you subtract the lower limit by replacing the value of small t with 0. Now obviously, according to the previous slide, if you remember, we already proved to you that omega 0 times t, that is equal to 2 pi. Omega 0 times capital T is equal to 2 pi. And therefore, you can see cos of 0 degree should be equal to 1. Cos of a multiple of 2 pi is also equal to 1. This fellow is also equal to 1. And therefore, the value of a is equal to 0. So the value of a is equal to 0. So in other words, I already proved to you that the integral of sine k omega 0 t dt is equal to 0. And that is exactly the equation that we have earlier that I was supposed to prove, if you remember in the previous slide. You see? So we already proved to you that the integral of sine k over 0t is equal to 0. Similarly, proof can be done also for the integral of cos k omega 0t. So I'm not going to talk about that. Let's go on to another example. Let's take a look at example 2. Let's say equation 11, we want to figure out what is the integral of sine square of k omega 0 t dt. Now from high school year, using some trigonometric relationship, we can express sine square of an angle in terms of cosine of a double angle, 2 alpha, as shown in equation 12. So make use of equation 12 right here, make use of this equation. We can replace the sine square of that angle by this square bracket right here, shown in equation 13. And now you can see it will be a lot easier to integrate this equation 13 rather than to integrate equation 11. And obviously, the integral of 1/2 dt is equal to 1/2 times small t. And then the integral of the second term, is given in here. Alright? In other words, the integral of cosine of 2k omega 0 t, it is equal to sine of 2k omega 0 t, and multiply with this factor in here due to the chain rule. Now after that, we just evaluate this square bracket between the capital T and the lower limit 0. So if you replace this square bracket, you replace a small t with a capital T, this is what you got in the first bracket here. So this square bracket you get is basically come from the previous square bracket, and then you replace a small t by a capital T. And then for the lower limit, small t equal to 0, if you plug back into the square bracket here, everything is 0. So this is what we have from equation 14. So let me continue this equation 14 on the next slide. You see we have the first term is t over 2, and the reason is because that comes from right here, that's t over 2. Okay? And then the second term is supposed to have minus 1 over 4 k omega 0 times sine of that. This is exactly the second term. Okay? Now obviously from this equation you can see sine of a multiple of 2 pi should be equal to 0. This term is equal to 0.